Hello everyone. Last class just we discussed about the complex number and why it's required and the concept of the iota values. Just I'm going to recall in the last video we learned iota power is a 4, n is a 1 and iota the power 4 n minus 2 is a minus 1 and similarly we learn about the different value power of the i's values iota values. So now I'm going to explain continuous of this one that I'm going to explain on the questions that related to the iota. So question is we have to find the value of, question is given that find the value of 1 plus iota power 2 plus iota power 4 plus iota power 6 plus dot dot iota power 2. We have a given here question and we have to get the value of this one. So we have a conceptual easily we can find there is two cases we can consider here. So we have a given series is nothing but 1 plus iota square plus iota power 4 plus iota power 6 plus dot 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 plus iota power 2. So first case is if you're going to see here, first case suppose n is the suppose we have an odd. Okay, so n is odd here we have. If n is a odd, so what will get the value here? If odd means suppose we have a just basic example, I'm going to say 3, 5 or 7 like that we can use here. So just I'm going to consider a basic things. Suppose n is a 3. So what you will get here? We'll get a 1 plus iota power 2 plus iota power 4 plus iota power 6. What the value will get here? If you find here, so we know that I square is a minus 1 and I power 4 is a plus 1. Correct. And I power 6 is the minus 1. So what we are getting? Similarly, if n is a 5. So we'll get 1 plus iota power 2, iota power 4, iota power 6, iota power 8, and iota power 10. You will get that. Okay. So again, if you solve this value, what we get here? Total terms we have a 6. So we know that I square is the minus 1. This one I power 4 is the plus 1. I power 6 again minus 1. Here we have I power 6 is the minus 1. I power 8 is a plus 1 and I power 10 is the minus 1. So again what will happen is we are getting 0. So we can conclude here if n is odd then the sum is 0. Easily we can find here. Okay. So we can say that if n is odd, n is odd numbers, then sum of 1 plus I square plus I power 4 plus I power 6 plus that I power 2n becomes. And if n is an even number, then what we get here? We are going to get here. So if n is even means suppose of n is a 2, n is a 4, n is a 6. So if you're going to take like that, n is a suppose we have a 2. So what we get here? We'll get here 1 plus I power 2 plus I power 4. What will get? 1 minus 1 plus 1. So we are getting 1. Similarly, if n is the 4, what will get here? 1 plus I power 2, I power 4 plus I power 6 plus I power 8. So here again we'll get here, what will get here? 1 minus 1 plus 1 minus 1 plus 1 again we'll get the 1. So again we can conclude that if n is a even, okay, if n is even, this one we can consider a case 2. Suppose in case 2 if n is the even number, then summation of this value is 1 plus I square plus I power 4 plus I power 6 plus that plus I power 2 it becomes 1. Okay, so we are getting here. Okay, so short form you can also write this one. What we can write summation of I power 2n I equal to 0 to n. Sorry, n is equal to 0 to n, we can consider like that. So if 0, then you will get 1, so on, so on, so on. This value becomes 0 if n is odd, 1 if n is a even number. So this is the final answer. These questions we can consider as a theory or as a numerical source. Next, similar questions I can explain. We have a question. We have a question here. Suppose we have to find the value. Find the value of summation of n1 to we have a given n1 to 13, and the value we have n power n plus sorry I power n plus n plus 1. We have a given question. So we have to find the sum of these values. What we can do here, if you know the direct formula, we can use here. But I'm going to elaborate and explain all the steps here. How we are going to get, and later we can study the solve form also. How we are going to get the value of this sum. Okay, so if you start here like n1 to so on up to 30, so we'll get two series here. First series we are getting like that I to the power n of 1 to 30 plus I to the power n plus 1 I to the power n1 to 30. If you expand this series, we'll get here 1 n is the 1, so we get first terms I power 2 I power 6 sorry 4 plus dot I power 30. Similarly, here we'll get I power 1 2 here I power 3 I power 4 I power 5 dot plus I power 40. By putting 1 we are getting 2, by putting 2 we are getting the 3, so on, so on, so on. Right? Now we can find here. So here we have a total number is a 30. We are going to count the number, it will be 30. Okay, so we know that this number we can break odd and even count. Odd and even count. Okay, like suppose we have then I for like whatever value we are getting third like that we can use here because I4 will get the 1. Okay, I square we are getting the minus 1, and IQ will get the minus I. So based on that, okay, we'll get the okay the value here. So now what we have to do, suppose if you find the values all this here. So here we are getting I power 1, 2, 3, 4, 5 like that we are getting here. So I1, 2, 3, so on. So what we get here? I plus IQ, I'm writing here, plus I5 plus I7 plus I9 plus I11 plus I30. I'm considering as one place. Similarly, remaining we have I power 2. I'm just using I power 2 plus I power 4 plus I power 6 plus I power 8 plus I power 10 plus I power 12. You'll get the complete I value in this one. Similarly, here also we can do the same way. I power 2 plus I power 4 plus I power 6 plus I power 8 plus I power 10 plus I power 12 plus I power 14. We can consider. Okay. I power 14 plus. Remaining will get here I power 3 plus I power 5 plus I power Here we'll get a 7 plus I power 9 plus I power 11 plus I power 30. So we know that I power k is the minus I and here plus I both are cancelled. I power 5 is I power 7 minus I, this also get cancelled. And I power 9, I power 9 will get the I, and I power 11 is the I power 9 will get the minus I. So it cancels. So here we are getting I power 30. Similarly, here I square minus 1, I power 4 is a 1. So this cancels. I power 6 is a minus 1, I power 8 is a plus 1. Both are cancelled. Okay, and here we are getting 10. I power 10 is the again minus 1, I power 12 is the 1. Similarly, here we can say I power 2, I power 4, again these two cancel. Again these two cancel. Again these two cancel. Here we have I power 14. I power 14 will again will get that minus 1. Yeah, I power 12 is the 1. So I add it to I square, that is minus 1. And okay, and next what we get here? I power 13. I power 13 we get the is the I. So whatever the remaining terms we have right here. Okay, so again we have I power 3 and here I power 5. I power 3 is the minus I power 5 is the plus I power cancel. Similarly, I power 7 is the minus I power 9 is the plus I. Both are cancelled. I power 11 is again we have to calculate it. It will come uh, minus I, and I power 13 is the plus I. So what we have a I power 13 plus I power 14. And we know that I power 13 we can add I power 12 into I, and I power 14 we can add I power 12 into I. I power 12 is the 1 to iota, and I power 12 is again 1 to I square is the minus. So we are getting here I minus 1. So the sum of this value is n 1 to 13, and I power we have the value n plus I power uh, n plus 1 becomes I. This is the final answer. Okay, this is a basic concept. Okay, so this is the concept, this final answer. Okay, so similarly, we have the different kinds of questions we can solve based on this concept. Again, we have one questions I'm going to explain here. Questions we have suppose summation of iota power is factorial n, and n is starting to 2. Yes, we have a long method also we can solve, and this also we can use the sort method here. So how we are going to make is this one is sort method. So we know that I power 4, generally we are getting 1. So we have to break in that way 1. So if we start here, this value summation of this n, if we are going to start 4, and here we have 100, and this I power we have a factorial, we can write. Okay, and this one we can write summation n equal to 1 to 97. So we have taken your starting 4 here and 200, and if you start 1 to 97 both have that I power n plus 3 5. Just a scaled theorem unit of this n is scaled. Okay, if you use this concept here, what you get? Just you put your value, you'll get your I power 0, I power 0, 0, 0, 0 till 97 terms, up to 97. So this value becomes a 97. Okay, and if you want to break this terms, this one, so we can break like that. I equal to 0 to e iota power factor plus we can break n 4 to 100. Okay, iota power factor. Okay, so this value we have, this value also we have, both value we can write. So this value we are getting here 97 we got here. So here what we are getting, if you add these two, so this value becomes a 95. Then calculate here, just to calculate, you get a 95, and this value will get it. So this is the value here. If you solve here, you get this one. I will get this one because already we have this one 97 value, and this one we can write here. We'll get like that 97 plus we get here like I plus I minus 1 minus 1. If you solve this one, you'll get this. Okay. So that's all in this video. Next video, I'll start basic so complex number, like how we are going to represent a complex number plane, and why we are saying that complex number is the name is number, but it's not a complex number. It's like a plane, a point in a complex plane, and based on that concept, I'll discuss in the next class. Today, just try to solve some basic questions. Okay, so thank you, and I'm wind up the class.